All right, so in the last lesson, I had gone through two examples of how to find the molecular formula. I want to work through two more advanced problems, and these are actually from a worksheet that you received in class, a worksheet on finding formulas. And I'm going to skip on down to number 4 and number 5 because these are a little more complex, and so I want to show you how you would handle these. So let's look at 4 first. Number 4 says a compound is found to contain 85.64% carbon and 14.36% hydrogen by mass. It has a molecular weight of 42.08 grams per mole. Find the empirical and the molecular formula. So in this problem, unlike the ones in the notes, I'm not giving you the empirical formula, but I am giving you enough information to find it. Notice I gave you both percentages. They always add up to 100%. So what we have to do first is we got to do the empirical formulas calculation. I'm going to do that first, the empirical formulas calculation. So the way we do that is percent to mass, mass to mole, divide by the smallest, and round to the whole. So 85.64% carbon, we're going to assume that's 85.64 grams of carbon. And we have 14.36% hydrogen, so we're going to assume that's 14.36 grams of hydrogen. Again, remember the percentages will add up to 100%. Now, using your periodic table, we need to go grams to moles. So percent to mass is what we just did. Now we're going to mass to moles. So we need to convert to moles, and that's going to be a one-step problem. So we need grams of carbon on bottom. So we're going to use the atomic mass of carbon, 12.01 grams per mole. And then for hydrogen, we need grams of hydrogen on bottom. And that's going to be 1.01 grams per mole. So when we divide here for the carbon, we're going to get 7.131 to 4 sig figs because we have 4 here and 4 here. And for the next one, we need to round it to 3 sig figs because this has 3, so 14.2. So this is mass to moles. Now the next step says divide by the smallest and then round to the whole. So the smallest number here of moles is 7.131. So we need to divide by 7.131. We're going to round this to a whole number, which will go 1, and that'll round to a 2. This means that our empirical formula has 1 carbon, so C1, and 2 hydrogens, H2. So this is our empirical formula. Now this is the point that our problem started you off with in the notes examples from the last video. So now we're going to find the molecular formulas. I'll put MF calculation under here. This doesn't take very much room. So what you want to do is add up the molar mass of the empirical formula. So carbon is 12.01. There's 2 hydrogens, so 2 times 1.01 gives you 2.02. And that's going to give you 14.03 for your empirical formula's molar mass. Now, all you want to do now is see how many times this number will go into the true molar mass, which is given as 42.08 grams per mole. So we're going to say 14.03 into 42.08. And when you divide that into there, you're going to see that it's going to go exactly 3 times. So that means that our molecular formula is 3 times larger than the empirical formula. So we would say that the molecular formula is 3 times the CH2. So C3H6 will be your molecular formula. All right. Let's look at number 5. This one's even a little more challenging. Let's read the problem carefully first. It says a compound contains only, this is important, only nitrogen and oxygen. And it is 30.4% nitrogen by mass. The molecular weight of the compound is 92 grams per mole. What are the empirical and molecular formulas? Well, if it only contains nitrogen and oxygen, but they only give you 1%, what do we know about both percents? What do they have to add up to? And that's right, 100%. So they're giving us the percent nitrogen. So how can we then find the percent oxygen? Good, we're going to subtract from 100. So to get your percent oxygen, you're going to say 100 minus 30.4. And that's going to give us the percent of the oxygen. So when you subtract, you get 69.6% for your oxygen. So now We've got the percent nitrogen and the percent oxygen. Now let's start our empirical formula calculation. Percent to mass, mass to moles, divide by the smallest and round to the whole. So I've got 30.4 grams of nitrogen. I got 69.6 grams of oxygen. So let's convert that to moles. So I got to divide by 14.01 grams per mole for the nitrogen and 16.00 grams per mole for the oxygen. This will give us our moles. So I get 2.17 moles for the nitrogen and I get 4.35 moles for the oxygen. Now divide by the smallest, which is 2.17. And that's going to give me a 1, and this will go in twice. This means the empirical formula equals N1O2. So this is your empirical formula. Now let's find our molecular formula. So the molecular formula calculation is I'm going to need to first find the molar mass of the empirical formula. So NO2, that's going to be 14.00, and then we have 2 times 16, which is 32.00. If you add those together to get your molar mass, you get 46 point, that should be 14.01, sorry y'all. This gives me 46.01 grams per mole. So see how many times this will divide into the true molar mass. They gave that to you in the problem, 92. So you're going to say 92 divided by 46.01, and that will go twice. That means your molecular formula is N2O4. Okay, so here are 2 answers for that problem. All right, that's it for our extra examples of molecular formula.